Now a bar magnet is generally a rectangular shaped small piece of magnet, that is small piece of rod, or you can say of iron or cobalt or nickel, generally iron, having north and south poles of same strength separated by a small distance. Now bar magnet is also called the magnetic dipole. As we have, you can compare this magnet with our electrostatics. We have already studied electrostatics. In electrostatic, electric dipole is what? It is a device or it is a system with two charges of equal magnitude but opposite in sign separated by a small distance, like same. Bar magnet or magnetic dipole is a what? Is a assembly of north pole and south pole separated of same strength separated by a small distance. Or magnetic dipole consists a pair of magnetic poles. One is north pole, other is south pole, separated by a small distance. And let us say this is north pole, this is south pole. Strength of the pole is denoted by Qa. This is the strength of each pole. That is, strength of north pole is Qm, strength of south pole is also Qm, but their nature are different. The separation between these two poles is 2L, as we have written in the electric dipole. Then this is called magnetic dipole, or you can say this is a magnet, bar magnet, right? Now, the distance between the two poles is called the magnetic length. Distance between the two poles is magnetic length, but the distance between the two ends of the magnet is called its geographical length, or you can say is length of the magnet. But magnetic length is different from the length of the magnet, right? Length of the magnet is the length between two ends of the magnet, but magnetic length is length between the two poles of the magnet. Poles are near the end, but it is not at the end. Clear? It is just near the end. So you can say this magnetic length is smaller than its length. Magnetic length of a magnet is smaller than length of the magnet. Clear? Rather, the ratio of the magnetic length and length of the magnet is nearly equal to 0.86 or 0.85. Now, the line joining between the two poles is called the axis of the dipole, axis of the magnetic dipole or axis of the bar magnet. Middle point of the magnetic length is called the center of the magnet. That means if you join these two poles to get a straight line, this is called axis of the bar magnet. If this is middle point, then this is called center of the magnet. Center of the magnet. And the quantity M, which is a vector quantity, Q into 2L. 2L, this is a vector, and this 2L vector is the magnetic length directed from south pole to north pole. South pole to north pole. This term is called magnetic dipole moment. Magnetic dipole moment. As we have defined in the electrostatics, electric dipole moment P equals to Q into 2L. Here we say Qm into TL is the magnetic dipole moment. where qm is the pole strength and ql is the magnetic length of the bar magnet, and its direction is from south pole to north pole. That means the direction of capital M, which we have defined as magnetic dipole moment, is from south pole to north pole. SI unit of pole strength, that is QM. SI unit of pole strength is ampere meter, and SI unit of magnetic dipole moment, SI unit of magnetic dipole moment is ampere meter square. When we have discussed that a current carrying loop behaves like a magnetic dipole, in that discussion we are told that magnetic dipole moment is equal to I into A, that is current through the coil into area of the coil or area of the loop. Now current I is unit of the current is ampere and unit of area is meter square. That's why ampere into meter square, right? And this magnetic dipole moment can be written as this, and from that you get the unit of QM, which is ampere meter square divided by meter. You get ampere into meter.